Okay, this is the second video on hyperbolas, section 9.4. And this one will focus on hyperbolas where the center is not the origin. So for example, if you're given this equation, instead of just having x squared, it has x plus 2 quantity squared, and same over here. It's y minus 1 quantity squared. So this basically fits in the form of x minus h squared and y minus k squared. This is exactly the same thing we did for the circle and for ellipse, and now this will be the same for the hyperbola. Okay, so whichever variable comes first, that'll be over the a squared, and the other one, the one you're subtracting, will be over the b squared. And the h and the k, those will give you the center, h, k. So that's how that works in general. So this is one where the transverse axis is not going to be the x-axis since we're shifting the center, but it'll be horizontal. All right, and we know that because the x is the one that comes first. Okay, so we have in this one that a squared is 49, so that gives us that a is 7, and b squared is equal to 25, so that gives us that b is 5. Okay, so we're basically going to graph it using the center hk, which in this case, better write it down, h is -2 and k is +1, so -2, 1. Okay, so we're going to go to that point. I'm sorry, let me make sure the center is -2, 1. We're going to go to that point and graph from there. Just kind of pretend it's the origin while we do the rest of it. So we'll go to -2, 1. Okay, that's going to be the center. So in your mind, you're going to graph it like you did the ones where the center was the origin. So for example, a is 7. So we're going to go 7 to the right. 1, 2, 3, 4, 5, 6, 7, and that's going to be a vertex. And then 7 to the left of the center. 1, 2, 3, 4, 5, 6, 7, and that'll be the other vertex. Okay, and we know that the branches are going to open to the right and to the left. Now the b value is 5, so that helps us draw the rectangle to get the diagonals, to get the asymptotes. Okay, so from the center, go up 5. 1, 2, 3, 4, 5, and then down 5. 1, 2, 3, 4, 5. And then you can picture where that rectangle would be. And then you would draw in its diagonals. And the center of the rectangle is going to be the center of the hyperbola. So everything should match up. So we can see the slope on this. You're going up 5, because that's what's with the y, so that's like rise, and then over 7. So up 5 over 7. So if you wanted it to continue it, up 5 from here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, just kind of helps you draw it a little straighter. But that's going to be the asymptote. All right. Okay, and it goes this way. Remember, it is supposed to be a dashed line. Okay, and then you got the other one going through here. Okay, and then we don't need the rectangle. The rectangle just helps you find the asymptotes, that's all it does. Okay, so the hyperbola is nestled in between the asymptotes, and the vertex is an actual point on there, just like that. Okay. All right, so we end up with 1, 2, 3, 4, 5, 1 is one of the vertices, and then that was -2, 3, 4, 5, 6, 7, 8, 9. -9, 1 is the other vertex. Okay. another question says, find the standard form of the equation of a hyperbola whose vertices are located at 1, 6 and 1, -2, and whose foci are located at 1, 7 and 1, -3. All right, now it doesn't say that you have to graph it, but usually that's what I do. So I can really kind of picture the situation. So if I put the vertices on there, 1, 6 and 1, -2. Okay, that's a vertex. And then down here is a vertex. Okay, so you can already see this is going to be one that opens up and opens down. And so the transverse axis is going to be vertical. All right, and then we've got the foci, 1, 7 and 1, -3. That's the other one. Okay, so we know that it's going like that. We don't really have to graph it. It's just kind of a helpful visual. All right, so where's the center? Where's the center? All right, well, if you have a really nice graph, you can just find it. It's going to be exactly in the middle between these points. So you could probably count 1, 2, 3, 4, 5, 6, 7, 8. They're 8 spaces apart. So half of that, 1, 2, 3, 4. Here's where your center is going to be. Okay, now you can also do the midpoint. Okay, center is at the midpoint of the vertices. And you have a midpoint formula. If you take the two vertices, if you add their x coordinates together and divide by 2, average the x coordinates, and add the y coordinates together and divide by 2. So you average the x coordinates, you average the y coordinates. That gives you 1, 2, okay? Which is what we came up with by looking at the graph. So that's going to be our h, and that's going to be our k. All right, so we're thinking, since it's a vertical transverse axis one, that it's going to be y minus k squared over your a squared minus then the x minus h squared, okay, equals 1. All right, so what's the value of a? So we could put it in here. Well, go back to your center. Here's the center, here's a vertex. How far apart are they? Well, we were just looking at that distance. That was 4. So that tells us that a is 4. So this tells us our a squared, 4 squared will be 16. All right, so a is equal to 4. And then b, not as direct on here. So what you could do is use c. C is the distance from the center to a focus. That amount is c. So you can see in this one, it's one more space than a. So c works out to be 5. So we have c is 5. And we have the rule for hyperbolas that c squared equals a squared plus b squared. So 25 is equal to 16 plus b squared. And if you solve that out, you're going to get b squared is equal to 9, or b is equal to 3. But actually, we only need b squared for our equation. Okay, so we pretty much have everything we need to know. We know that the center is 1, 2, so we know h is 1 and k is 2, and we found that a was 4, so a squared is 16, and b squared is 9. So those are the things we need to put into the form y minus k squared over a squared minus x minus h squared over b squared. Okay, so go straight to the answer then. So it'll be y minus 2 squared over 16 minus x minus, oops, I had to put 2. It's going to be 1. X is always minus h squared over 9. And then that's equal to 1. So that would be the standard form. Okay, one last problem. Okay, find the standard form of a hyperbola whose general form is. Okay, so this is like what we did with circles and ellipses. You need to do a completing the square process. You are going to complete the square on the variable x as well as the variable y. All right, in this one, you can see that x starts off with a negative coefficient. So we're going to be looking at a form like the last one we did, where the y is the one with the positive coefficient. So let's write the y's first. So we'll have y squared and then minus 2y, and then we'll put the ones with x. Minus 4x squared minus 16x, and then you add the constant to both sides. That's equal to 19. Okay, so you're going to complete the square on y and complete the square on x. You're actually ready to do it on y since it's 1y squared. You're not ready to do it on x because there's a negative 4 there. So we'll have to factor out that negative 4. All right. When we did the ellipses, we weren't usually factoring out a negative. It was a positive. So you got to be a little more careful with the negative. When you factor out negative 4, you're dividing by it. So it's going to be x squared plus 4x. All right, so then we'll put plus what we're going to need to add in there over here, y squared minus 2y plus what we're going to need to add in there equals 19. Okay, so it's the same process when you get to this point. Negative 2, take half of that and square it, so that would be 1. So we're adding 1, so we can just add 1 over there. For x, in here, negative 4, divide that by 2 and square it. So that gives you 4. Now, you didn't really just put 4. You did negative 4 times 4. Negative 4 times 4, which is negative 16. So we're going to need to subtract 16 over there. Okay, and then we have, this is y minus 1 squared minus 4 times x plus 2 squared equals 4. Okay, and then in standard form, we do need it set equal to 1. So whatever number you have for your constant, that's what you divide by. So in this case, it'll be 4. So we're going to divide both sides by 4. So over here, we'll have y minus 1 quantity squared divided by 4. Minus 4 divided by 4 is just 1. So we'll have x plus 2 quantity squared. I'll put it over 1 because it would make it easier to graph it if I was going to graph it. All right, so then you could see that the a squared is 4 and the b squared is 1, and then you could do whatever else you needed to do. This particular problem said find the standard form. So here's the standard form.